are studying the book of Genesis here in our adult class this quarter, and we're going to be based out of Genesis chapter 1 today. So if you want to go ahead and flip over to the first chapter of Genesis, that's what will be kind of our home base for the class today. Last week we began talking about the events of Genesis 1, the creation account, and I grossly overestimated what I could accomplish in one class period. So today is part B, or part 2, of last week's class, which is covering the creation account. Just as a quick refresher, more for me than for you, and I'll tell you why in just a second, the days of creation. So we know from Genesis chapter 1 that on day 1, God separated the light from the darkness. We talked last week about how the first major events in Genesis 1 were about God taking the chaos that existed from what was there and then bringing order to that chaos. And the first thing he did was separate light from darkness. And then on day 2, he separated waters on earth from waters up in the sky, bringing more order, more structure to the earth and to the universe. Then on day 3, he separated the waters from the land. And on the earth itself, he brought dry land together and separated the land from the oceans and from the rivers. And then he took the order and structure that he had created, and then he began to populate all these areas with life and with the various celestial bodies up in the sky. And so on the second part, the latter part of day 3, he put plants onto the land. On day 4, he created all the heavenly bodies, the stars, the sun, the moon. On day 5, he put birds into the skies. He put fish into the water. So he's populating these areas with life. And then finally on day 6, on the dry land, he then put all the land-dwelling animals and also man. And I have to apologize because last week I didn't sing my song enough times, and I repeatedly got days 4 and 5 like totally mixed up. So just to set the record straight, on day 4, God created the sun, not on day 5, despite what I may have said last week, so I apologize for that. But this is our outline for the events that took place there in creation. We're going to focus today, though, on really the latter part of creation, when he creates life, and talk about how do we know, what are the evidences that the life that we have, our life, the life of all species on earth, all plants, all animals, all bacteria, how do we know these came from God, from an intelligent designer, and not from random means of evolutionary processes, which is the sort of the other account, if you will, of how life came into being. Now, we know from biology that all living things share a lot of very similar features, right? We're all composed of cells. We all have DNA that tells our body what to do, what proteins to make. And all of these similarities between all life, ourselves all the way to bacteria and plants, are sort of fodder for evolutionists to say, well, because we're all so similar at that basic level, we all must have come from one common ancestor and not from some divine creator, which is what we would, of course, contest. And so you have these two sort of competing ideas about the source of life on earth. One is called common descent, and one is called common design. Common descent, or common ancestry, is the sort of evolutionary theory about how life came into being. And what it basically says is that all life on earth eventually arose from one common ancestor, all right? And so many billions of years ago, life came into existence. It was very, very simple. And then over many years, that life evolved into all the various species that we have here on Earth. And you'll see, pictures like these have shown up here where they break down, animals and fungi and plants and bacteria into these groupings. And with these sort of line diagrams, they illustrate the similarities in various organisms and how those similarities perhaps branched through evolution to generate the various life we have on Earth. That's one theory. The other theory about how life came into existence is common design. And common design is the assertion that an intelligent being, God, created all life on earth. And the reason for the commonalities that we share with other living organisms is because you had one creator, one designer, who used his palette to generate all these life forms. He didn't revolutionize the creation of life through different mechanisms, but he used one kind of common theme, cells, DNA, proteins, to make all life. All right, and we're going to look at sort of these two ideas for our class today and kind of come to hopefully a consensus on which of these is perhaps the most accurate. All right, so when you're talking about the study of order in the universe, the study of life and structure, as an argument for the existence of God, we call this the teleological argument, or the design argument for the existence of God. And this is perhaps best illustrated in the Bible itself. All right, in Romans chapter 1, Paul says, "For since the creation of the world, his invisible attributes are clearly seen, being understood by the things that are made, even his eternal power and Godhead, so that they are without excuse." The Bible itself pretty much sums up the teleological argument, all right? Paul says right there in Romans that what you see in the world, all these evidences are the actual proof, the evidence for the divine nature of God and his creation of all of the universe, including the life found therein. Other passages also attest to this. Job wrote in Job chapter 12, "But now ask the beast, and let them teach you, and the birds of the heavens, and let them tell you. Or speak to the earth, and let it teach you, and let the fish of the sea declare to you. Let all these things speak, declare to you. Who among these does not know that the hand of the Lord has done this?" And then in Psalm chapter 19 and verse 1, "The heavens are telling of the glory of God, and their expanse is declaring the work of his hands." Throughout the Bible, we read, and it tells us the things you see around you, the mountains, the valleys, the rivers, the water cycle, life itself, the sun, the cycle of day and night, the cycle of the seasons, all of this order you see in the universe, that is the evidence you need for the proof that God does exist. And that right there is the teleological argument for the existence of God, that there's no way that all of this order and structure could exist in the universe. There's no way that life itself could exist without a divine and all-powerful creator to have set these things in motion and to sustain them. Okay, so we're going to use an analogy right here. Okay, so this right here is a painting. In a moment, I'll ask you who the painter was, but just look at it for a second. Here's another of this person's works. Here's another of this person's works, and then a fourth. All right, so before we talk about who the actual painter of these works is, what do you notice about these four paintings?
They're not good.
Okay, they're kind of weird. That right there is commonality, though. All right, that right there is commonality. Jenny,
Because I can only see real portraits is my real
right. Jenny, what do you call this style of art? This is cubism. I don't know what that means, so ask Jenny later on if you want to know what cubism is. But this is cubism right here. All right, tell me what you see about them. Just very generic kinds of things. They're kind of strange. Okay, the faces are sort of distorted. Yeah, they're kind of strange, distorted faces. Anything else? The colors are not of like natural human skin tone colors. Yeah, the colors are kind of strange. So you might know who I know Jenny does, but you might also know who the painter of all this is? What's that? Yeah, this is all works of Pablo Picasso. All right, so Pablo Picasso, or any artist for that matter, tends to have a style, right? And his is strange. That's his style, at least that's how I would name it, right? But what you can see from these works is that he didn't paint typical, very, very normal pictures of people. He painted these portraits of people that were distorted and sort of off and strange. That was his style, all right? he used one palette of colors and his own style was the best word I can think of to generate these pictures. And if you took a different artist, all right, and looked at their works, then you would see commonalities in their works. You would see their style. If you take an engineer, all right, who designs buildings, or an architect who writes plans for buildings, if you take anyone who generates works, he or she has a typical style. And they usually don't deviate very far from their method of doing things, their style, all right? That right there is what you think about when you think about common design in the universe. All right, God had his method of doing things. When he created the universe, when he created life, he had his style, okay? He used cells, he used DNA, he used proteins, all right? He used arms and legs and head and a brain, right? He didn't suddenly just go all crazy with lots of different styles. He used one common theme, one common set of tools when he created the world, when he created life, right? That right there is the idea of common design. When one person, when one being creates things, the tendency is to work within your wheelhouse. Now, God's wheelhouse is infinite, right? He could have done whatever he wanted to do. He wasn't bound by anything, but he still chose to do things in one general set of ways, right? We know all life has DNA as its basic genetic component. We know all life is made of cells. Those are the commonalities that we all share because we all have one common designer. All right, so this right here is a common picture that you'll see in science textbooks as evidence for evolution, okay? And what this is sort of designed to show is that various organisms, you see fish, turtles, chicks, pigs, cows, humans, right? This is a sort of diagram of the embryonic development of each of these organisms, all right? And if you look right here, you see that, you know, in the early embryo, humans don't look that much different from the fish or the turtle, right? And then as the embryo develops, they begin to diverge, and they begin to look, you know, much more different. But early on, we look a lot alike for the very, very early embryos, okay? This is commonly used as evidence for evolution, that the similarities that we have with other organisms during embryology is evidence for we all must have come from one common ancestor. But when I look at this, I see those pictures of Picasso. I see one common theme that is trickled down through these different organisms. I see not common ancestry, but common design. Just like Picasso's works all look very similar, this also looks very similar because we're all made of the same genetic material. We're all made of the same kinds of proteins. Another typical picture you'll see is this right here. This is showing you the limbs of different mammals, whale, cat, bat, gorilla. And, you know, all these different animals, they're all mammals, so we know we share those features. You know, they all have one bone, basically like the humerus. There's two bones in the forearm, radius and ulna, you know, and then there's several bones here in the hand. You got your carpals, metacarpals, phalanges. They're different sizes, but very, very similar kind of general bone composition between these different organisms. Again, commonly used as evidence for evolution. The reason why they all share the same, you know, bones, the same skeletal system, is because they all came from that same common ancestor. But once again, when I see this, I see common design. God said, okay, all mammals are going to have these bones. They'll look different. We'll put different things on them. Some will be fins or flippers. Some will be feet. Some will be wings. Some will be hands like we have, like the gorilla has. But there's the same basic architecture to each of these bone systems, each of the skeletal systems. All right, so we have these two competing ideas about these similarities that we see in the life around us. Questions, thoughts? I don't want to talk the whole time, so feel free to jump in if you have something you want to say or ask. Okay, so what are the evidences for or against these two ideas? So the first evidence against common descent is probability, okay? And even evolutionists will say this. The probability, the actual likelihood that enough genetic changes would have taken place over even the time scale of millions to billions of years to generate this much diversity in all life on Earth is astronomically small, okay? As in, so many one followed by so many zeros that you can't really write that number, right? The probability of random chance generating this much variation, this much order and structure to life is really just astronomically small. And when you think about evolution, these two words right here are usually put together by evolutionists, but they're very, very different, okay? So let's talk a little bit about microevolution from macroevolution, all right? So who was sort of the author of evolution? Y'all know? All right, Charles Darwin, yeah. So when Charles Darwin, he was on this ship, and he sailed through the Galapagos Islands, and he observed nature and life, and that's what, basically, he wrote Origin of Species based on that voyage. And one of his famous things that he observed were these finches that lived in different islands of the Galapagos. And what he observed was all these finches that lived in different islands, they all had very different beaks, all right? And what he observed was the beaks were sort of specialized to help them eat different things on different islands. Some beaks were better for eating fruits. Some beaks better for eating and catching insects. So different food yielded different beaks. And what he said was, oh, these finches have specialized their beaks based off of their environment, the island that they're restricted to. They've developed a specialized beak they can survive and eat the food on that given island. All right, that right there is called microevolution. All right, when one organism undergoes changes, all right, based on their environment to specialize, all right, to survive and to thrive in one set environment, all right, there is no change in the actual organism itself. It's still a finch. But each finch is a little bit different, okay? Now, we see this very readily in ourselves, right? All right? Why do some of us have white skin and blonde hair? Why do some of us have very dark skin, dark hair? Why is some of our hair straight, some of our hair curly, right? All the variation, even in human beings, that is microevolution. Those are small changes at the level of DNA that generates diversity within one specific species, like humans, right? Dogs, right? All dogs are still dogs, but if you take a Rottweiler and a miniature poodle, they look a lot different, don't they? And you would think, those are two different animals. Well, they're really just dogs, but through, again, microevolution, small changes, you can get these big changes in the gross level of the actual animal, okay? But what Darwin did was say, if this could happen, then he made the leap that this could happen. Macroevolution is, again, these small changes that lead to a sudden change from one organism into another organism. So macroevolution is the idea that we came from monkeys. That small changes in the monkey DNA eventually led to a totally new species altogether. So monkeys then became humans, or fish came from bacteria, okay? That's macroevolution, all right? Here's the problem. We know this occurs, right? We can observe this. We know it happens. There's no direct evidence that this occurs. That's the actual leap itself. The only evidence for macroevolution is really in the fossil record, and that's more up for interpretation than anything else. Right? In fossils, you can see this organism is here, and then a different organism is here, and the different layers in geology. Right? And the leap is made, oh, well, this one became this one over time, but that's still a leap. There's no direct evidence that that became that from these fossil records. Okay? But that's the leap that is made to prove evolution. that we know this happens, and so we assume, or at least evolutionists assume, that this can happen. Basically scaling up the small into the big. No change in the organism to a change from one organism into a different, more advanced organism. Microevolution to macroevolution. They're two very different ideas, but they're sort of grouped together and assume if one can happen, the other can happen. So it's all going to be the same. It's all just evolution. All right?
Well,
Yes.
so, the first thing you were talking about there was like the scientific community believing that the probability of this is astronomically small. Isn't that the kind of thing that they would normally rule out? If probabilities of something are astronomically small, they start looking for other theories rather than adopting that as their position.
Well,
what am I missing there?
in this case, the only alternate theory is common design, and there's a staunch disregard of that altogether. And so common ancestry is the only theory. Even though the probability is astronomically small, it's the only option because they have a complete disregard for the other, because that involves magic. That involves supernatural events, a supernatural being. So that one couldn't be the case. So they're left with one solution, even though the odds are stacked far against them. Other questions? Okay, number 2 here. This one's really sort of my favorite itself. Okay, so if I take this book right here, if I take the Bible, okay, if I take every letter of this book right here, put them all into a bowl, shuffle them all together, and then throw those letters out onto the ground, what are the chances that my Bible is going to end up being read by those letters? Astronomically small, right? I mean, in theory, it could conceivably happen, but the chances of that happening are astronomically small, okay? Bacteria, very simple life forms that we supposedly arose from, have a small amount of DNA compared to how much DNA we have. All right, we're more complex. We have more DNA, more proteins, etc. For bacteria and simple life forms to evolve into more complex life, you don't just have to have changes. All right, you have to create new information. Okay, you have to create new genes in the DNA that code for new proteins. You have to create new information. New information is never generated through random events. Random events can't actually create new information. All right? For anything to generate new information, there has to be a design to that. Someone has to intentionally do that. All right? So that's what's one of the other problems with the other idea about where life came from is this information problem. All right? Random events cannot generate new information. DNA, which is the code for life itself, for all life on Earth, cannot acquire new information over time due to random chance. There are 6.2 billion base pairs in our DNA. All right, in human DNA, 6.2 billion base pairs that codes for around 20,000 different proteins. All right, that number is much smaller as you work your way down into more simple life, like bacteria and so forth. All right, so for bacteria to become humans, you got to generate new DNA, has to make a bigger DNA genome with more genes and more proteins. You have to generate new information. It's not just random reshuffling of what's there. It's actually creating new genes that code for new proteins to make us more complex, which we are more complex than simple bacteria, simple organisms. So that's the other problem with evolution, all right, or common ancestry, is this idea of information itself. There's no way for random events, random recycling of letters in a book to suddenly come out in order that makes sense, but even more so, there's no way for that random shuffling to generate new words, okay? So think about it this way. If I took the letters in my Bible right here and threw them on the ground, could I regenerate the Bible? Yes, but the chances of that happening are, again, astronomically small. What about generating a new book altogether? Could I take these letters, shuffle them up, and generate not any book we know of, a totally new book that makes sense? That is the problem with new information. You can't take material that you have and through random chances generate something completely new and novel. The only way to get a new book is if someone sits down and writes a new book. Random chances don't generate new books altogether. It just doesn't happen. But it has to happen for common descent to be a reasonable explanation for anything beyond the actual Genesis account. That God created all these things, that he purposed life, that he willed it into existence, and he was the intelligent designer that generated what we have here in the world around us. All right, I'm going to read an excerpt here from a paper or a booklet published by Apologetics Press with some other thoughts about design in the universe being just compelling. The Earth is slanted on its axis exactly right, at a tilt of 23.5 degrees. If it were not tilted, but instead sat straight up in its orbit around the sun, there would be no seasons. The tropics would be hotter, and the deserts would be bigger. If the tilt moved all the way over to 90 degrees, so on its side, much of the Earth would switch between very cold winters and very hot summers. In addition, the Earth is poised 240,000 miles from the Moon, whose gravitational pull is responsible for ocean tides. If the Moon were moved closer to the Earth by just 1/5, the tides would be so enormous that twice a day they would reach 35 to 50 feet high over most of the Earth's surface. So even beyond life itself, which to me is staggering how complex it is, but everything we see around us, there's structure to it. From the position of the Earth from the sun, not too close, not too far away, just right. The tilt of the Earth's axis, perfect. Distance of the Moon from the Earth to control tides, perfect. How the Earth orbits around the sun, how the Earth revolves about its own axis. All of these things, the level of detail, the level of order is staggering. How life could exist at all on Earth depends upon all these factors. From the temperature control to the seasons, to the two hemispheres, the tilt of the Earth, the tides, all of these factors dictate that Earth can sustain life. And then you move into, okay, well, where did life come from? Did it come from random evolutionary means, or did it come from God himself? Just as we read about there in Genesis chapter 1. So, in our remaining time together, so why is all this important? All right, why do we need to talk about this? Why is it important? So this right here was taken, I took an excerpt from the Alabama Standards of Science Education, okay, for all public schools in Alabama. And one of those standards for high school science is analyze scientific evidence. For example, DNA, fossil records, cladograms, biogeography, to support hypotheses of common ancestry and biological evolution. So it is basically law in Alabama that public school teachers teach this right here, right? That's why it matters. And this is true for basically all states, right? So regardless of whether it matters to you, it's going to matter to your kids. It's going to matter to your grandkids, to your friends, because the law says they have to be taught evidences to support common ancestry and biological evolution. So that's why it matters. Because when kids come home from school and they've been taught this, how do we, as parents, as grandparents, as Christians, combat this and give them the other alternative to what they hear about in science class? So now I want to hear from you guys. All right, those of you who've been through school, those of you who maybe have kids in school, what do you do? What do you do when this is what happens to your kids when they go to school?
I tell them to come see you.
I may not be around. Yeah, Ryan.
I was gonna say, I remember when, I had science class, a long time ago, but I was in, ninth grade, Coach Crowder, and he said there, when he introduced the subject, he said, this is the point where I'm required to talk about evolution. He said, I don't believe it, but I have to teach it. And a lot of teachers are actually saying that, and they're kind of being very cursory in how they do it, especially this area. That I think that there are a lot of teachers that they will go through the basics, but they really don't go much further than that.
Yeah.
Because they don't believe it themselves.
So,
I won't say that that's all across the board, but that's been my experience.
okay, Ray.
Well, I experienced when I was teaching, even 8th grade, I took the Bible and I had the students to bring in their Bible. And we set them down, and then I taught both sides. Evolution as
Mhm.
described here, and the other side, the Bible itself, creation. I was called in after about 5 or 6 months. I was called in by the principal that said, you are going to be fired if you don't stop this. And what had happened, an old man in the community who happened to be a scientist, and he said that this man is teaching wrong. I was shut down immediately. And so I said, okay, it's fine. So I told the kids, take your Bibles home and let your preacher teach you.
Yeah.
Had to be done. That's all I could do.
Yeah, I once went to a job interview for a teaching position at a state school, and I was asked during the interview. I had to give a example, mock teaching lecture, and they asked me a question afterwards, and I was asking the question. So, how does evolution play into what you just talked about? And it was a totally benign question on their part. And I said, well, I actually don't believe in evolution. I think, creation is the more accurate account. And you could hear a pin drop in the room when I said that. And then at the end of the interview, the department chair told me, you're not going to get hired because of what you said. I mean, they were taken aback that I actually said that. Because here's the thing is that your kids are going to be told, all scientists believe in evolution. That just burns me up because it's totally not true, right? All scientists do not believe in evolution, but a lot of them do, and a lot of them are very, very vocal about it. And so it becomes this reverberating theme of, oh, it must be all the scientists who believe this because that's all we hear about. But that's not the case. But they assume that I did, and when I said that I didn't, it was momentous right there in the room based on their reaction. And yeah, it's very difficult in the public setting, public high school, public colleges, to do anything different because there can be repercussions.
I will say this, that the community where I was teaching was in an uproar just about this. They came to school and they said, look, this man needs to be teaching this. This is what we demand.
Mm-hmm.
And so that put a little pressure on the school. But at the same time, all I was doing was saying, students, you reason for yourself. Here's the
Yes.
Bible. We'll present this, and then we'll present evolution. Now, which one do you think makes more sense? Well, even the students, 8th grade students. So, well, we don't believe we came from a monkey.
Yeah. But the problem is the actual standard itself leaves no room for presenting the evidence and letting students make the decision.
You don't.
It's very clear. There's no mention whatsoever of an alternative.
Well, you're going to be tested on that.
Yes.
The test will come from that.
Yes. Yes.
So you have to stay.
So, other thoughts, other experiences? Jana?
I teach first grade, and the beginning of that standard is even in first grade.
Yeah.
I mean, that's how young, it's very basic, but
Yeah.
they're building, how much, children look like their parents and how we're equipped for survival. And, it begins in first grade.
Yeah, if you actually read the standards at every level, there's hints of it all along the way. And then when you hit high school, it all comes together as one clear standard. But you were totally correct. There are hints of it at every level along the way.
And well, it's just all over the place, it's in, just, you can't pick up just a standard book about dinosaurs and it not begin millions and millions of years ago.
Right.
And so,
Sorry.
we had to sort of be careful as we were sort of picking out books for Jonathan, and it's like, well, I guess if we're gonna get him a dinosaur book, it's gonna come from AP because,
Yeah.
it's, the only place that, it's not gonna throw in, something that we don't want, it's very easy for that to just sort of become an understood thing with them, right? Millions and millions of years, right? You see it in, 10 or 11 places, well, that must be the truth.
Yeah, when it's as pervasive as it is across everything, then you just assume, oh, well, that must be the case. Like you assume there is no alternative.
We skip the first 3 minutes.
Do what's that?
Any dinosaur movie, like Land Before Time, any of the cartoons, we skip the first 3 minutes before we watch it, because it says millions and millions of years ago.
Well, how do they combat us evolving today? I'm not growing any wings. I don't see any humans out there that can.
It happens on such a slow time scale.
Yeah, but we've been talking billions. When was the first man, supposedly?
I don't know the numbers.
I don't even know what their number is. If it's billions of years ago, then, obviously in my mind, we should have no deficiencies. I should be able to see millions of miles away.
You should be Superman.
Yeah,
by now.
Really, yeah, I should have wings. If we're really evolving,
Yeah. Well,
in that way, that would be my argument. Well, why are we not doing this?
I mean,
Show me an example.
what we said is it happens on such a small, slow time scale. We wouldn't observe that ourselves. But at the same time, we've been
Which goes against science.
we've been selectively breeding animals for hundreds of years, right? Dogs, cows, to optimize, the meat we get from a cow, or to optimize the breeds of dogs. So we've added our own pressure to those breedings beyond random chance. They're still cows, they're still dogs. They haven't suddenly become anything different or better. So even with our own selective pressures added, we take the 2 best cows, breed them together, so we get the best cattle, the best milk, the best meat. But even our own sort of meddling with breeding, what comes out is still just a cow. So even that says we can add our own pressures and we still can't recreate this other idea, which is random evolution.
If I was going to evolve, why would I want to evolve to be that bug versus the person who steps on that?
Hopefully you're going to be moving up in the food chain, not down. All right, thank you for your attention. I'll see hopefully some of you guys again next week.